Thank you, audience, joining us in person and online from around the world. I'm Song Guanfu, the chairman and the CEO of SuperMap. Today, I will introduce GS Root Technologies that we have innovated and how they laid the foundations for geointelligence application. Nowadays, geographic information technologies have been applied in many fields. Among them, digital government is one of the most important applications. As a digital society, digital defense, and industry digitalization. To support this application, we need geointelligence. Several years ago, SuperMap provided the concept of geointelligent pyramid. It has 4 levels: geovisualization, geodesition, geodesign, and geocontrol. From top to bottom, the technologies become more mature. To support geointelligence, GS platform software plays an important role. Several years ago, we published 5 technology architectures that compose of Big Data GIS, AI GIS, 3D GIS, distributed GIS, and cross-platform GIS, simply as BitDC. Therefore, we said that GIS platform software is the root technologies of geointelligence. The latest version we launched also brings a lot of upgrades, including multi-source video spatialization based on Big Data GIS and AI GIS. 4 new features of 3D GIS, Cloud Native GIS 2.0 of distributed GIS, open source spatial database Yukon, and the others. And I'm going to elaborate upgrades in these aspects. My colleague will detail the other features. Several days ago, we released SuperMap GS 11i. In this version, we used many brand new technologies. One of them is Yukon. Yukon is an open source spatial database that SuperMap developed in partnership with Huawei. The word Yukon comes from the title of an ancient Chinese geography masterpiece. Why do we need the spatial database Yukon? What is the benefit of developing it? Let's figure out these questions from the database ecology. PostgreSQL is the so-called world's most advanced open source relational database. As a spatial database extender for PostgreSQL, PostGIS is open source as well and adds support for geographic objects. At present, it doesn't support for 3D model yet. Particularly, we need to do a lot of extensions. The other open source database is OpenGOS. It is highly ranked in China. It becomes the top 1 in May this year. It is mainly developed by Huawei and customized based on PostgreSQL, but it lacks of alternative extension of open source databases. For such reasons, we launched for an open source spatial database, which is much stronger than PostGIS. In the meanwhile, supports 2D and 3D integration. What are the advantages of Yukon? Since Yukon is maintained by SuperMap, we can upgrade spatial data models quickly according to the development of GS technologies. It can analyze spatial data on the backend, greatly improving the spatial analysis performance. Besides, Yukon is open source and data formats are open. Therefore, other GS and serving software manufacturers can use it directly. The technical architecture of Yukon can be divided into several layers. Features with the label new listed in this architecture are extended from PostGIS, and more capability will be provided next version. The yellow 2D polygonal data used in this video was stored in Yukon. Both SuperMap iDesktop X and QGIS can access it. In this video, we stretched a 2D building polygon dataset saved in Yukon to a 3D dataset with a field that record heights of building, and then open the resulting dataset with SuperMap iDesktop X and QGIS. In addition to the capabilities we introduced before, Yukon supports for 3D models like beam data. You can manage your beam data with Yukon, browse and analyze data with SuperMap and other GIS software. You can get Yukon from these websites. Apart from Yukon, SuperMap also provides other open source products. You can find them from the GitHub website. The second technology is Cloud Native GIS 2.0. We launched the technology of Cloud Native GIS 1.0 in 2018, including microservice, containerization, and automatic orchestration. In the era of 2.0, we introduced service mesh and serverless computing. Service mesh provides 4 abilities. Service metrics can count and make the statistic of service communication. Service trees can detect exception during the running of services, and then administrators can process them immediately. Access control refers to setting the access permissions between services to ensure that a service can only be accessed by authorized services. The last one is gray release. So what is gray release? The old procedure of upgrading an application system was like this. First, we developed an application system and allow your users to use it. After we updated, all users were required to upgrade. But some users may not want to upgrade. In this situation, we can adopt the gray release technology. Users who want to try the new version could upgrade the application. And conservative users can switch to the new version step by step. This technology makes application release more smoothly. Another new technology is serverless computing. We disassembled the computing module of microservices into function level granularity. And then you could execute, extend, and pay for function on demand. During the whole computing procedure, you don't need to manage any infrastructures like servers. The spatial microservice technology evolved 4 times. Before 2018, the whole WebJS was a monomer service. In 2018, we broke it down into many microservices, each of which could run on a separate container. In 2020, we split each common JS microservice into smaller microservices. Last year, we split each analysis microservice into fan analysis services. And this year, we broke each spatial analysis microservice into functions. Every function can run independently. This is a real-time topology diagram of background service provided in SuperMap iManager product. The nodes on the left and in the middle are workloads that continue to reside, such as microservices, and on the right are various spatial analysis functions. Once a request comes, related function instances will be called. After the code start is complete, the spatial analysis will be performed immediately. As soon as the task completes, these replications will be destroyed and resources will be released quickly. This is a comparison test. We found that the size of container images was reduced by about 60%. The speed of starting a container was increased by 144%. Overall, we found that performing spatial analysis with serverless is much faster and saves more resources. Here are advantages of CloudJS 2.0. Service mesh makes service management smarter. Serverless computing makes data processing faster and more flexible and help save resources. The third section is about 3D upgrades. The latest version of SuperMap.js provides a series of 3D highlighted technologies. I will introduce 4 key technologies. The first of all is S3M 3.0 upgrades. The second is Hi-Fi 3D SDK with enhanced performance and effects. The third is Hi-Fi 3D Scene Browser. The last one is Web 3D SDK, which is brand new. The first highlighted technology is S3M 3.0. Not both the performance and effects are enhanced. Compared to S3M 2.0 and 3.0, updates these capabilities. First, it supports data compression, greatly reducing data size and improving the data access speed. And then it supports OBB bounding boxes, making the scheduling of spatial data more accurate, thereby improving the performance. And next, it supports skinning and skeletal animations, making animations on scene more diverse. It also supports PBR materials and mask texture, making visualization effects much cooler. The last, mesh model can save multi-dimensional vertex properties. We tested the performance of S3M 3.0. The results show that data size can be reduced by 30%. Memory usage can be reduced by 40%, and loading performance is almost twice that of S3M 2.0. The second highlighted technology is a Hi-Fi 3D SDK that both the performance and effects are enhanced as well. We provided 3D GS plugins for game engines like UE4 and Unity before, and then they could access spatial data and performance spatial analysis. This year, we provided a plugin for UE5. We call them SuperMap Hi-Fi 3D SDK. There are more special effects in the new SDK, like the change of light, the effect of sunset, the simulation of running and throwing. The spatial effects improved obviously. Additionally, we provide some post-processing effects, such as screen space reflections. From the video, we can see the sky and buildings reflected in the glass of the building on the left. We provide powerful abilities to beautify the scene, like the stretched buildings blocks. It is generated based on 2D vector data, hence it is a little plain. To beautify it, the old way was to attach texture and model, but the result is not satisfying. So how to make it more realistic and make the whole scene more shocking? Now, we can distinguish the types of materials according to the floor intervals and map them. Compared with the stretched building blocks, the granularity of BIM is finer and refined to components such as pipes, doors, and windows. BIM is highly accurate, parametric, and has detailed semantic information. Its physical types are so clear. Therefore, we think their materials express physical types like metal, glass, stone, and the like. And then we replace materials in batches for each type of components according to its physical type, beautifying the scene. The fine model does not have as fine-grained object representation as BIM. A single building may be an object. There are not too many details on mesh and no semantics. The details are mainly expressed through texture. So what should we do to distinguish the windows, walls, and doors on the side of the building? We could give semantics to objects with the technology of mask texture, so as to beautify the scene at the detail level. SuperMap Hi-Fi 3D SDK also supports physics engines, such as flowing water particle system. It takes gravity into account and is very close to the real scene. An engineer of UE China developed this demo by combining UE and SuperMap Hi-Fi 3D SDK. It simulated an airplane that took off in a low visibility snowy day. After flying to a certain height, we can see the situation above the clouds, and a big city appears on the screen, on the scene. UE5 provides a coordinate system for larger scenes, and after we support UE5, large scene like a big city can shown on a scene. Achieving the macro integration. The third highlighted feature is the Hi-Fi 3D Scene Browser. It is a new product. The product name is iExplorer 3D. It is a desktop product for browsing 3D scene data. It is developed based on UE5 plus SuperMap Hi-Fi 3D SDK, and it is for free. It has three features. The first feature is it supports massive multi-source data. The second is it supports Hi-Fi rendering effects. The last feature is it supports cloud rendering and allow to publish to the website. All of these screenshots are from iExplorer 3D. We can find that iExplorer 3D supports various data. The fourth highlighted feature is a brand new Web 3D SDK. The open source product, Season, released Season.js earlier. Although it supports the developer ecosystem, its capabilities are not that powerful for some heavyweight applications. Based on this framework, SuperMap wrote a lot of code and generated a product named iClient3D for Season. The product supports low-code development, various data formats, and abundant data types. And recently, we released iClient3D for WebGL. It is a self-innovated architecture WebGL engine. It supports two low-code development frameworks and more realistic rendering. Besides, it provides more abilities and supports more data types. This is a rendering effect on the website. It supports irradiance maps of diffuse reflection and specular reflection. You can see the sky reflected on the glass and the light effects. We can simulate the snowy day on the website, including the effect of snowflakes and snow on the ground. This is a demo of screen space reflection on the web. On the website, the street after the rain reflects the building on the ground. We can export PBR materials of stretched building blocks from a UE and load them on the WebGL engine. The representation of scene is much more beautiful. Now, let's review the technologies I shared today. Brand new open source spatial database Yukon, Cloud Native JS 2.0, and 4 features of 3D. The motto of SuperMap R&D institutes is have the courage to do what nobody does. We have done many world-leading researches for developers and provide cutting-edge technologies like Cloud Native JS 2.0, helping users create more JS values, and we will keep cultivating in advanced technologies. That's all for my presentation today. Thank you all for your time.